Okay. So basically, I'm going to go through the wiring of how this connects up. Now, I actually have done a PowerPoint presentation based one, and I watched it again after not having seen it for 3 weeks last night, and went, oh my gosh, it's actually really hard to understand unless you've got my brain that's been doing this for a while. Okay, so I'm going to try my best to do this in a way that that will work. So basically, we're going to start off with our battery. Our battery is sitting here, and our battery is 1650 batteries, okay, or 16350 batteries, and each one is 3.7 volts. They're in series. What does that mean? Series circuit. What does that mean if you add two voltages together in series? You add them. Yep. So that gives us 7.4 volts. Okay, and an important number for us as well is if you've bought your batteries, it should tell you on the side of the battery how many milliamp hours they are. And if you put milliamps in series, it doesn't add. It just stays the same. Okay, so we're looking at, for mine, I'm looking at 4,000 milliamp hours, which is 4 amp hours. Okay, so 4,000 milliamp hours of power. So basically power will be 7.4 times 4, which gives you, if it worked for an hour taking 4 amps, then the battery would be completely kaput at the end of that hour. Okay, that's what it's basically saying. So we've got our battery, and then I'm going to basically use a little bit of blue tack here, and we're going to come down to our switch. Our switch is a rocket launcher switch, is what I call them. Okay, and we're going to basically take our red cable. I'm going to draw the red cable in, and the red cable is going to come down from our battery into our switch like so, and connect up there. The black one is not going to connect to the switch at all. We're going to connect the red one. The red one is the positive side, otherwise described in circuits as the VCC, the positive side. It's coming in at 7.4 volts. If I plug 7.4 volts into my Raspberry Pi, it would fry it. It would be an overcooked Raspberry Pi. So basically that's why I've got this little circuit board here, which is a power converter. Okay, and the power converter is going to take out one of those out of the middle pin into there, and you need to look up the diagram to actually see which one it plugs into. Okay, and that's going to drop it down to 5 volts at 2.5 amps. That's going to drop the power down to 5 volts at 2.5 amps, and I'm going to basically plug that into a Raspberry Pi. That's a Raspberry Pi Zero, not the Raspberry Pi Zero W. This is an old one that I blew up ages ago. And I'm going to basically just stick that down there. Okay, that's stuck down. And we've got the Raspberry Pi Zero, and it goes into the 5 volts of that one there. Straight in. The black cable, let's just try and stick these guys up out of the way. So stick that one out of the way and that one out of the way, so that I can't see them. Well, they can see them, but they're just not in my way. The black cable is going to come straight out and also go into here, and then we're going to have a black cable, the ground, into the Raspberry Pi. So we've got that powering our Raspberry Pi. We can't also use that to power our motors, because motors, when they spin, actually generate electricity. So if you actually got a motor and put a fan on it and blew on it, or put it out in the wind, you would generate current from the back of the motor. So they work backwards as well as forwards. In fact, most electronic circuits actually work backwards and forwards. So basically, if you're going to have that happen, you need to isolate it somehow. Plus the motors also need a higher voltage. So I'm going to basically put this guy up here. This little guy up here is a very similar circuit, except it gives out 6 volts at 2.5 amps. Okay. And what we do is we take a second one off there and plug it in. So we split that cable there. And on our black cable, we also split it off, and that's just by soldering it. So we just basically cut a cable, get two ends, and we just join it. This is called a splice, basically. And we splice it and we separate it out like that. So you've got that wiring going into there. Now, notice that there's 5 amps here. if these were pulling all of their current, if all of the current was in use for 5 amps, who can tell me how long this battery should last if they're both pulling 5 amps? So if they're both pulling 2.5 amps, that's 5 amps together, how long will this battery last? 48 minutes. So people just went, oh yep, 48 minutes, that makes sense. Who doesn't get that? I'm expecting that some people will go, how the hell did they come up with that number? Right? How they came up with that number. If 4 amps is going to last you a whole hour, but you're pulling out 5 amps, then 4 over 5 of 1 hour is going to be 48 minutes. So 4/5 of an hour. Okay? So basically, if we were running our robot at full ball and it was pulling 2.5 amps on both circuits the whole time, it would last for 48 minutes on full charge, which is enough for us to get through a lesson. In reality, we'll probably never pull 2.5 amps off both channels at both times. The battery is more than enough to handle this situation. Okay, so out of this 6 volt amp, 6 volt power supply, we're going to take it into our, and I'm not sure if I've got these the right way and the diagram's not going to make total sense, but we're going to run the power in, the voltage in with an earth, and with the 6 volts into our driver, our motor driver. So our motor driver is going to basically run at 6 volts. Now the tricky part is that we then need our motors to be driven, so we've got 2 motors over here. Let's pull that off. We've got 2 motors, and I'll put them in over here. We've got 1 motor and 2 motors in over here. And those 2 motors, I'll use a green, are basically going to have an A channel and a B channel. Okay, so that's grouped and that's grouped. Okay, so those 2 motors are going to run out on an A channel and a B channel. So those 2 motors will work off that one controller. The final thing we will then need to do, and I'll use a different colour, I'll use pink and I'll use orange, is run some control cables out of the Raspberry Pi, 2 for here, that could be the A side, and actually it probably should be the B side looking at where it is, 2 pink ones into there, that can be the B side, and they run into that motor controller as well. That's basically an overview of how we're wiring it up. The soldering that you'll have to do, and you'll have to do that hopefully this week, which you've only got this lesson, plus if you want to come in this afternoon, you can come in this afternoon. Can't do tomorrow afternoon, but basically the soldering you're going to need to do to be able to complete this is the soldering at the switch from the battery to the switch, this splice here, and making sure that these are all done as well. Has anybody, apart from Gustav, not got those done?
Yeah,
okay, so
one of the, I think the 6 volt.
Yeah, okay. So as Adam pointed out, shotgun is not absolute in this thing. If you call shotgun on the soldering lines, that's not absolute because I need to get certain people caught up as a matter of priority. Any questions on that?